So hello everyone and welcome back to another Overclocking Basics episode. This time a bit more focused on power limits. So I've talked about power limits in the last Overclocking Basics video about graphics cards. And today I want to get a bit more deeper into the topic. Like talking about how you practically deal with power limits, how they affect your graphics card's performance, and also how to get around them for NVIDIA and AMD. So first things first, let's start with the easy stuff. So in the last overclocking video, I told you to just max the power limit. That's still pretty true. And likewise for AMD and NVIDIA, even though for AMD, like AMD lets you increase the power limit pretty substantially sometimes. So using my RTX 2080 Ti as an example, we can see in GPU-Z, I have an adjustment range of minus 67 to plus 22%. So I can increase the stock 300 watt value to 366 watts, which, by the way, the default value is already higher than for most 2080 Ti's, which is already one way how you can get around power limits, which is by flashing the BIOS from another card. So my card, being a custom one, does have a 300 watt default power limit, whereas a normal 2080 Ti should have 250 watts. So yeah, but let's get into that later. So you can see on NVIDIA cards you have like about that adjustment range. Plus 22% is already one of the higher ones. There are some cards that can only do like 15, 16%, some can do 17, 20. It's in that range. Whereas on AMD cards, the older cards can do plus 20%, and the newer cards like my RX 570 can do plus 50%. Now, plus 50% is quite the increase. So, yeah, I would still say to max the power limit, because technically the card should be designed for that. Unless it's an Asus card, because my RX 570 Expedition, well, that one blew up. Even though that probably was a faulty MOSFET. I still, I would say it's 99.9% safe to just max the power limit on AMD. It's just like, maybe you should look into what VRM your card is running and then determine for yourself if the VRM can take the extra power. But yeah, so maxing the power limit will definitely increase your performance, because the power limit is connected to the GPU boost algorithm. Both NVIDIA and AMD have one. They work a bit differently, but the way the power limit is implemented is basically the same. So when the GPU boost algorithm determines the clock to run at, it takes several things into, it looks at several things. It looks at temperature, it looks at how much voltage you have right now, and it looks at the power limit. And for the most part, your power limit, especially on NVIDIA, your power limit is the limiting factor. So most of the time, you have situations where the voltage is, okay, like maybe you could go a bit higher. Sometimes you are at max voltage, but temperature most of the time is low enough to boost higher. And you don't really have, the voltage thing is a bit weird. Especially on NVIDIA. Like on AMD, you can still set a static voltage that you want. NVIDIA the voltage just fluctuates to whatever the card thinks is good. We're gonna get later to this perfcap readout from GPU-Z. But yeah, so the main thing is, most of the time, your GPU boost algorithm will determine it can't boost higher because you are at your power limit. And if you raise that power limit, it's going to take the GPU boost algorithm longer to hit that wall. So you get more boost out of your card. And that, will boost your performance, because now it's running faster. If you're not running into one of those other walls, like if you have a OEM card that's running really hot, you're probably going to hit a temperature limit. But most of the time, it's a power limit that you're hitting first. So raising that power limit will give you performance for free, basically. And so raising the power limit is one of the easiest, bit more advanced overclocking techniques, because you can just max the slider as a beginner and then you're set, but for some people that's not quite enough. So coming back to how you can increase the power limit. So yeah, I've already mentioned flashing BIOSes. So if, let's say you have a reference 2080 Ti and you have your 250 base and then maybe a 300 max power limit, but you want more, you could just flash the BIOS for my card or another card that might even have a lot more power limit to it, and then you would have like when the BIOS flashes correctly, because there are some limitations. Like you can't just flash every BIOS on every card, but usually they are compatible. There's just some limitations. And if you flash that BIOS for a custom card that has a higher power limit, your card will now, with the new BIOS, have that higher power limit. And since the reference PCBs even for the 20 series are pretty good, the card will take it. Like there's no problem with that. The VRAM won't blow up. And yeah, so that's one way to get around the power limit. Same goes for AMD. It's just flashing on AMD cards is a bit more restricted. But if you flash a 5700 XT BIOS on a 5700 XT, just from a different model of it, it should still work, I think. I don't really have a lot of experience with AMD cards, but technically there shouldn't be anything that should make it not work. And so before we get to other methods to get around the power limit, we have here from GPUC the sensors tab. And these are all the power readings that my 2080 Ti gives out, and these are quite a lot. Most of the time you're just going to have this, this, and this. And sometimes you get this. All this extra stuff is like things that my 2080 Ti shows, but most cards won't. Like you can see how much power each connector is pulling, even how much I'm getting from the PCI Express, all that fancy stuff. Because NVIDIA, especially on the 2080 Ti, has implemented way too much power balancing garbage. And by the way, there should be a fan now that you can hear. That's the Surface Pro 7 that I'm using to draw on. For some reason, the fan is going full tilt right now, even though I know for a fact the CPU is at like 50 degrees, because it's always at 50 degrees. Yeah. So sorry about that if you can hear it in the background now. There's really nothing I can do about it. I can't control that fan. So coming back to GPU-Z. So the ones I've marked should almost always be there. The GPU only thing is not always there, but the other ones should. Well, and AMD cards do not have this perf cap thing. Or do they? I actually don't know. Older ones don't have it. So to abort power draw, that's like at the top, that's the metric you want to look at, because that's the total power consumption of the entire graphics card. And you can see where I took the screenshot. I was pretty close to max, because I took this at stock, so I had the 300 watt wall. And you can also see we're at 96.3%, and actually it says here PWR, which means we do hit the power limit. Because perfcap reason gives you the reason why the GPU boost algorithm won't give you a higher clock. And the reasons are power and VREL. VREL means just it's at the maximum voltage it will go to, which is this. Like the card stock won't run a higher voltage than this. And it hits the power limit. Like the power limit, that's the important part. Why it won't boot higher. Clock higher. So, yeah. And increasing that power limit, so I can now draw at 366 watt, well, then it's going to take until it says 122% right here, until we get the power limit. And basically the same thing is on AMD, even though you might not get the perf cap reason graph. But yeah, I mean, that's what the power limit does. It sets a limit on your power consumption. And if you hit that, the GPU boost algorithm will either lower the clocks or just not boost any higher, because the GPU boost algorithm wants to keep the card in spec, and it won't allow the card to draw more power than it's rated for. And yeah, so always max the power limit, because that's just free performance. Of course, don't be too enthusiastic with it if you have like a weak VRM on your card, or like it's running really hot, because then it's not gonna give you anything. But usually you can just max that. And yeah. And now we can get to the bit more advanced part. I'm still going to explain it on a basic level, but this is how extreme overclockers get around the power limit. And not just they tweak it a bit so they get more, like how at least sometimes you can just completely get around it and like completely disable it. So we're going to go into NVIDIA cards first, because AMD and NVIDIA do use different systems for power monitoring. And this right here is a picture of my 980 Ti Strix that I took. It's a pretty old picture, but like it does have everything visible that we need. So yeah, these three things, these are 5 milliohm shunt resistors. And these shunt resistors are used to measure the power consumption of each of the 12 volts power sources that the card has. So the PCI Express slot and the 2 8-pins. These are the 12 volts power sources on your card, and each of these three has one of those shunts. And these shunts are connected to a chip called the INA3221. I don't see it on this PCB, it might be on the back. But GTX 600, 700, 900 and 10 series all have this INA3221. On the 20 series it was switched out for two different chips from ON Semiconductor that are NCP somethings. But the way they monitor the power, they work the same. Because they use these shunt resistors and they measure the voltage at the input and the output of that shunt. So we have a diagram down here. And on the left, the power goes in, and on the right, the power goes out. And since that's a resistor there, and resistors do drop voltage, you lose a very, very slight amount of voltage, because, well, it's just 5 milliohms, that's not a lot of resistance, it's very little, actually. So, yeah, instead of 12 volts, you might get 11.9975 volts. And the INA3221 measures both of these voltages, and then compares them. And because the INA3221 is programmed to know that the shunt has 5 milliohms of resistance, it can now, with the voltage difference, calculate how much current is going through there. And with how much current is going through there, it can calculate how much power is coming from that 12 volts power source. And that's how the card knows how much power it's pulling. So one way to get around this that doesn't involve BIOS flashing, because, well, earlier models up to the 900 series, you were able to just make a custom BIOS. You just took the BIOS from a card, plugged it into an BIOS editor, and then you could just take the power limit and set it to whatever you want. Beginning with the 10 series, NVIDIA started to encrypt their BIOSes, so you can't make custom ones anymore, so the thing you were left with is just find a card that has a better power limit and try to flash that BIOS. But that didn't always work, especially for extreme overclockers. So what they did is a hardware modification. So let's say on that 5 milliohm shunt, we solder an 8 milliohm shunt on top. And since we just put resistors in parallel essentially, we lower the overall resistance. So in that case, we get 3 milliohms, and 3 milliohms is lower than 5. And since we now lower the resistance, but the INA3221 still assumes the resistance is 5 milliohms, we've now tricked the INA3221 in reading a different value. Because with changing the resistance, the voltage difference on the output of the shunt will change. But the INA3221 doesn't know we just changed the resistance, so it still assumes it's at 5 milliohms, and therefore uses the 5 milliohms to calculate how much power we're pulling. But since the resistance is lower, it will now result in a lower overall power reading on the INA3221. Therefore, we've just extended our power limit. That's like the easiest hardware modification that you can do, and it's kinda also the only one that works on the 20 series, because the other one Yeah, I don't think someone has gotten it to work on a 20 series card. It does work on 10 and older though, or partly on 10, because there's a thing that can happen. Yeah, so soldering an 8 milliohm shunt on top of the 5 milliohm ones is one method to lower the power limit, to extend the power limit, or to lower the value the INA3221 reads. And for most people this is perfectly fine. If you just want some extra power limit for some light overclocking, or just you want a higher power limit for dailying, because again on 20 series cards the VRAM can take it. Like, these VRAMs are extremely powerful. Like, my 2080 Ti has a 16 phase of 70 amp smart power stages. Though they're not gonna be running at 70 amps all the time, because then it would be very inefficient, 16 of those still are a lot of current that you can push through the card before you get problems. So yeah. And then there's the other method that is just no compromises, power limit be gone. And that's this method basically. So what this is this part right here is the padding below one of those shunts. So if you remove them, you will see 2 big pads and 2 small pads. The 2 big pads are for power transfer, so that's where the power goes through. The small pads are the ones that are connected to the INA3221. So there's one on the 12 volt side and there's one on the output side. And those pads are used to measure the voltage difference. So what you can do is you remove the shunt, you bridge the 2 pads on the 12 volt side, and then you bridge those 2 pads to the power pad of the output side and leave the current sense pad on the output side empty. What you then do is you create a voltage divider and connect that voltage divider, like I've put down here, to the sense pad on the output. And whatever resistors you choose for that voltage divider, you can completely fabricate a reading for the INA3221. Because now the reading won't change anymore. Because before, if you pull more current, like if the card suddenly pulls more power, there's more current going through the shunt, therefore the voltage difference changes, therefore the INA3221 sees we just had our power consumption change. If you do it like this, if the power no longer goes through the sense pad on the output, the reading won't change with changing power consumption anymore. So you can just dial in a reading that you want with the voltage divider, and the INA3221 will be completely fooled into thinking we are pulling exactly that amount of power every time we do anything. Like, we are constantly pulling, let's say, 5% of TDP, no matter if we're idle or running a benchmark. And that's how you can completely get rid of the power limit. It's just completely gone after that. Sadly, there is an issue. So on the 20 series, this just doesn't work anymore for some reason. Likely because NVIDIA put some new power sensing circuitry on the card that is separate from this from these shunt resistors. And that's probably where the card still gets the power reading from. So like, it doesn't work anymore on the 20 series. And there's also a chance it doesn't work on 10 series cards, because some cards have a normalized power limit, as it's called by HW Info. And that normalized power limit does not get changed by doing this mod. It's also a separate power limit that some cards have. Some don't, but some have. Take, for example, Boltzoid's GTX 1070 Dual. That one had the issue. So he made I think he actually made this mod. And he ended up running into the normalized power limit, and the card somehow still knew how much power it's pulling. I don't think it was ever explained how it works, but it's just like, there's a second power limit on some cards, and there's nothing really you can do about it. I think you can mess with it a bit, but you can't completely disable the power limit on a card that has this. You might be able to get around this issue if you flash a different BIOS, because it might be a BIOS thing. I'm not sure though. Like it's a thing that's not really explored, because like people who do this mod, there's already a few people who do this mod, and of that only a fraction have this problem, and of that only a fraction have enough time and are willing to investigate that. So yeah. So yeah, but on 900, 700, 600 series cards, this works. Like as far as I know, this should completely work. And then I mean on 500 and older, yeah, there's just straight up there's no power limit on Nvidia. So yeah. So now we get to AMD. There's also ways on AMD to get around the power limit, but that sadly involves all software tricks. So on AMD you were also able to make a custom BIOS in the past, but either starting with Vega or Navi, they also started to encrypt their BIOSes, so you can't make a custom BIOS anymore. It does work with Polaris still, which this is an RX 570, the picture is from Gamers Nexus, by the way. So yeah, this is not my card. I couldn't find a nice picture of an AMD card from me. So yeah, this is the GTA, this is the RX 570 Windforce, I think, from Gamers Nexus's review. This has a much nicer VRM than my Asus card, by the way. just putting that out there. Yeah. But the power monitoring on AMD, sadly you can't do a hardware modification because AMD doesn't use current shunts. There are no shunts on this PCB. There's no INA 3221. So if you want to get around the power limit on AMD, well, in the past you were able to do a custom BIOS. Now you're basically also stuck with the same thing as on Nvidia, just like take a BIOS from a different card that has a higher power limit. Or there are power play tables, I think that's how they're called. It's a modification of the driver, as far as I understand it, where you modify the driver into allowing the card to pull more power. Sadly, you have to do it every single time you reinstall the driver, I think. Maybe even every time you update. I don't really know. Like, again, I don't really have a lot of experience with AMD cards, but like there's a software trick you can do with the power play tables. But yeah, there is no really hardware modification that you can do, because AMD uses the inductors of the V-Core VRM as, so to say, current shunts. They are inductors, so they are not precisely like current shunts are like they have tight tolerances. Inductors do have a resistance like those shunts, but inductors do have, well, they are meant to be inductors and not current shunts, so the tolerances on their resistance is like really off. And that's why AMD's power reading is sometimes kinda weird. And this also explains why, like, the RX 570 has 150 watt TDP. But if you're in the system, you see you have a limit of 90 or 125 watts, for example. That's because an AMD card only sees the power that's going into the V-Core VRM. You still have VDDCI, you have VMEM, and then everything else on the, like, there's a PEX rail, I think. Yeah, that should be the PEX rail. And then like fans consume power, and then like all the display drive stuff consumes power, all the ICs consume power. Like, there's a lot of things on the card that consume power other than the core. And because AMD is using the V-Core inductors for power measuring, you only see how much power is pulled by the core. Everything else on the card is not factored into that power reading and essentially has no power limit. And that's also where all this news came from, where when the RX 580 launched, people noticed it was overdrawing the PCI Express slot rather heavily, because you only know how much power the core is pulling, you don't know how much everything else on the card is pulling, and therefore you can't really limit the power consumption. So yeah, that's how it works on AMD. It's really not ideal, but at least AMD has been doing it for longer than Nvidia did, as far as I know. I think AMD did power monitoring a long time ago, whereas Nvidia only started with the GTX 600 series, which is like less than 10 years ago. And yeah, okay, what just that? Yeah. So yeah, that's pretty much it about power limit. So again, yeah, the power limit is one of the factors of the GPU boost algorithm that determines how high your card will clock. And if you hit that power limit, your clocks will either just stop going up or they will go lower even. And if you extend the power limit, you have some more boosting headroom. And sometimes that power limit is so high that if you don't mess around with voltages or clocks too much, you just will never hit the power limit again. Like my card with the 366 watts, in my daily usage, because I have the power limit maxed normally, in my daily usage I just never hit the power limit actually, because the power limit is so high and I just don't stress my card enough daily to hit the power limit. There's some things that do stress it rather heavily, but most games that I play don't max the card so hard it hits the power limit, so I get the maximum boost, at least according to the power limit. There's still voltage and temperature limits, but the power limit is, for the most part for me, not an issue. And so yeah, power limit pretty annoying, especially on NVIDIA, but on AMD too. You can get around it, but if you're just a normal overclocker, like this is overclocking basics, this is meant for beginners, this is more just a this is how it's done and not a you should do it, because you shouldn't. Like flashing BIOSes can be pretty dangerous, you can brick your card with it. Doing hard mods, well, I think the dangers of that should be apparent. Your warranty will be voided into nothingness. Yeah, but that's just like a kind of deeper explanation of the power limits, how they work on AMD and NVIDIA, and a couple ways to get around them. Like if you're more familiar with overclocking, if you like feel more confident, maybe a couple months or a year down the line, maybe you could try it. Like RTX 3000 just handed my 2080 Ti's ass to it, so I guess these are pretty cheap now. I saw some for $500 and I paid 1.4K for mine. Oops. Well, I did have it for almost 2 years, so yeah, I just paid the early adopter tax for RTX, I guess. So yeah, I guess older cards will become pretty cheap once RTX 3000 is actually out, because it's not yet, it's just announced, and prices for 2080 Ti's are already like down to hell. So yeah, but I don't want to ramble too much now before we reach 30 minutes. So thank you all for watching, hope you enjoyed, and until next time, goodbye.